streaming. Okay. All right. So if there aren't any specific questions, I'm just going to kind of work through section 1.3, and then tomorrow we can start looking, just kind of reviewing some of the factoring. We have a whole chapter devoted to factoring, and it kind of touches on all the different scenarios that we'll come across in this class for factoring. But we'll save that for a little bit later. I'm not getting my notifications. That's strange. I don't know how to fix it either. Let's see, is it I'm on the right account? Maybe it's because I'm signed in like that. Let's switch this to this one. Maybe that'll fix it. Notifications an hour ago. It should be going now. Is it streaming? It is streaming. I don't know why it's not showing. Okay. I'm just going to trust that it's working. There's no reason for it not to work. It's been working thus far, so I'm going to just let it be. Okay, so let's kind of, yeah, I'm gonna do another attendance in like a few minutes because I understand. It's okay. Okay, I'm gonna type open. Hey Google, give me a random number 1 through 21.
Here's a random number, 19.
Okay, let's see 19. So it says, refer to this graph. The axes are marked off in 1 unit intervals. Solve when y is equal to 4. Right? So when our y value is equal to 4, we have all of this and we have all of this. Right? Which answer choice is that? This half a line and this one. So y equals 4. I think that's E. And stop me if anything is too fast or if I need to go back or explain or anything. Hey Google, give me a random number 1 through 21.
Here's a random number, 6.
6. Let's look at question 6. Determine whether the following equation defines y as a function of x. Is this going to be a function, yes or no, and why?
No.
Why did you say no over yes?
Because it's a circle and it's 2 y coordinates.
Right. Yeah, that's essentially it, right? So if we were to solve for y, right, we could subtract x squared from both sides. When we go to take the square root to get rid of this squared, that's going to force a plus or minus. Whenever we have an even exponent on the y, and like for instance, if that was y to the power of 4, we would have to do fourth root. Whenever we do an even root, we have to introduce plus or minus, and that plus or minus forces it to not be a function. So this would be a no. What's the time? Hey Google, give me a random number 1 through 21.
12.
Oh, my video's off? I didn't even realize that. Let's go 12. Can somebody tell me the domain here? Let me know if I need to work it out.
It's D, right?
D? Anybody want to second that or challenge it?
Or C, D or C.
Oh, backtracking. It's D or C now. Which one is it?
No, I'm sticking with D.
You gonna stick with D?
Yeah.
Here, let's work this one out. Let's work it out. Okay. So this is homework from week 3. And it comes from section 1.3 functions. I know Mr. Rance got on the call. Anybody else feel like they did not? Anybody on the call feel like they did not get attendance credit today, other than Mr. Rance? Let's hop over here. Okay. So this is question number 12. Question number 12. We have this. We have f of x. Oh, hang on, you're going too slow for me. This is question number 12. And we have this f of x equals, now on the bottom we have x squared minus 2x minus 8. That's the bottom. And the top is x plus 4. All right? And then it says find the domain. That's the domain. Man, I always get excited. Like when you guys come, then I start drifting in my mind to like, okay, what am I going to do when this class is out? Am I going to go outside? Am I going to go for a run? Am I going to do a workout? Am I going to eat? Am I going to take a nap? Am I going to game? What am I going to do? Go do some drives? What am I going to do? I don't know. I get excited. Okay, anyway. I'm getting old. And I don't get out much, so I get excited from anything. Let's see. Oh, so what's the domain, right? So in general, for something like this, a rational function, the domain is going to be all reals except any x that makes the denominator 0, right? So to find the x's that make the denominator 0, we're going to set the denominator equal to 0, right? So if we set it equal to 0, we got this, what? X squared minus 2x minus 8. We want to set it equal to 0 and solve, and that'll tell us the x's that make it 0, right? So to solve something like this, what would you do? What do you think? What does your intuition tell you? What is this called? What is this technique called?
Get the factoring.
Factoring, right? We're looking for two numbers that do what? What's going on?
They got to multiply to 8 and add to 2.
So they need to multiply to negative 8 and add to negative 2. What are those two numbers?
4 and 2. Negative 4, positive 2.
I think it's a negative 4 and a positive 2, right? Notice that negative 4 times positive 2 is a negative 8, and negative 4 plus 2 is negative 2. Okay? So these are two numbers that multiply to give us negative 8 and add to give us negative 2. Okay? So then now we can invoke the zero factor property. When two or more things multiply to give us 0, either the first thing equals 0 or the second thing equals 0. Right? Pro wizard playing stuff. What is this? Oh, D Monty. What are you doing? It's all good. So then if we solve, x equals 4 or x equals, so is the answer, okay. So we're saying that x basically cannot be negative 2 or 4, right? Because these numbers make 0 in the denominator. So then, say we were to graph this. We look at the graph of this solution. So here's negative 2, here's 4, and we're basically saying that all the numbers to the left here work, all the numbers between negative 2 and 4 work, and all the numbers to the right work. The only things that don't work are negative 2 and 4. So because we don't want to include those numbers, we're going to group them with parentheses. Right? So if this is the graph, to write this in interval notation, what's the far left? What's the far left here?
Negative infinity.
Negative infinity. Up until what number?
to the -2.
And then from where to where?
Isn't it -2 to 4?
And then what's the final one?
4 to infinity.
Okay. Infinity always gets what grouping symbol?
Or regular parentheses.
Parentheses, all right? In this case, the 2 and the 4 both get what grouping symbol?
A parenthesis.
Parentheses, right? It comes directly from the graph. And then we're going to group all of these sets with the union. What does parentheses mean versus square bracket? What's the difference between those? What's the difference between
One means
Go ahead.
one means that you're including the number, and the other one means that it's not included.
So which is which? That's correct.
So the parentheses is when you're not including the number.
That's
and
correct.
I think the other one is when you are including the number.
All right, that's exactly what it means. All right. So parentheses means we get really, really, really close to that number, but we don't include that number. Bracket means we get really, really, really close to that number, and we do include that number, right? So since we don't want to include the -2 and 4, that's why they got parentheses here. So this will be the final result. This will be the final result. That's not it. What I drew. Awesome. Okay, let's go with that. And let's thicken it up a little bit. We're gonna go like here. Okay. Let's hop back over. So now, which answer do we want to choose? Can you see it now? I think it's clear. Okay, we're gonna go see. Okay. Marking me present. No worries. The main thing is just be here as early as on time as you can, consistently, and then just make sure to get your stuff submitted on Pearson, and you can keep it moving. All right. So because of the dynamics of everything, hopefully everybody's able to take advantage of it and not fall by the wayside. I mean, I don't know how to make it any. I don't know if easy is the word, but accessible or doable, given the way everything is going. I feel like this is more doable than usual because you can kind of do what you need to do. Hey, Google, give me a random number 1 through 21.
21.
Oh, boo. All right, close. All right, let's try 21. Let's see what's going on there. Student stuff envelopes for extra money. Their initial cost to obtain the information for the job was $130. Each envelope costs this, and they get paid 7 cents. Oh yeah, I remember this one. Express the cost function. So we have a cost function, a revenue function, and when will the cost equal the revenue? Okay. So this is question 21 from my from this assignment. It comes from 1-3-63. Let's see. Let's work on part A, which is the cost function. So the initial cost was $130 to obtain the information, right? So we're going to say 130, and then it costs them 6 cents for each envelope. So we're going to say plus 6 cents times each envelope. I'm going to label the envelope as X, right? So then I'll show you what I'm writing in a moment. The revenue function. It says that they get paid 7 cents for each envelope they stuff, right? So then the final one is when will the revenue equal the cost? Equals the cost, right? So we have our cost function again. To obtain the information, it costs them $130, and it costs them 6 cents for each envelope they stuff. So this is how we capture those two notions. And then they get paid 7 cents for each envelope that they stuff. So they get this, all right? So then for part C, they're asking, when will the revenue function equal the cost function, right? So then we have this 0.07x equal to 0.06x plus 130. Now you can actually decide to work with the decimals. I'm going to clear the decimals by using the following technique. In this case, because the largest decimal places we have are two decimal places, I'm going to multiply the left and the right by 100. So I'm going to say the entire left-hand side of this by 100. I'm going to say the entire right-hand side of this by 100. All right. On the right-hand side, we got to distribute that 100. Okay. Let me get some space for myself. There's no need to try to jam myself over there. I got a digital board, so I can give myself some space. So I just said myself so many times, it made me think of this, what's his name? Jim Gaffigan joke. I'm probably not going to do it any justice, but I'm going to attempt it a little bit. He was talking about, he's like, I'm always going to the gym. And those guys, they have these mirrors up. Like, what are we supposed to do? Like, look at me. I want to look at myself while I work on myself. While I look at myself in Time magazine. Like, he went on, like, he had this running joke of where he was talking about people working in the gym, looking in the mirror, working on themselves, working out. It was like crazy. And yeah, anyway, awesome story. Okay, so let's keep going. Jim Gaffigan is hilarious, by the way. I got to do another one. There's another one where he does about bacon. I'm not even going to attempt that one. He literally goes on for 15 minutes just talking about how great bacon is. It's the funniest thing. It's so funny. Anyway. All right, so if we multiply both sides by 100, on the left we get 7x. Then we get 6x here. And we still got our 130 plus 2 additional zeros. Right? So 13,000. We can subtract 6x from both sides. On the left, we get x. On the right, we get 13,000. That's it. Wham, bam. Thank you, ma'am. We are done. Right there. Style. We're going to go here. All right. 13. Let's see how do we do. Let's go here. So the cost function, we got 0.06x plus 130. Okay. The revenue function, 0.07x. Okay. And then they don't turn a profit until they go beyond 13,000. Yeah, you get partial credit, but you get unlimited attempts at these assignments. So, like, say you're working this question and you get something wrong. If you say you don't get the full credit, then if you click similar question down here, you can do it again, and if you get it right, it'll give you full credit. It's set to take your max score, right? So before the due date, we can get 100% on any assignment, right? Unlimited attempts. Just keep working until you get whatever score you want. Past the due date, the highest we can get is a 90. Hey, Google, give me a random number 1 through 21.
12.
12. We did 12, so we're going to go to 13. Use the vertical line test. Is this a function, yay or nay? Is this a function, yay or nay?
No.
No, right? Because when x is -1, you see these 2 points fail the vertical line test here. They're on top of each other. Is this graph a function? We're going to say no. So, is there anybody on campus at Morehouse right now? How does that work? Is there anybody in the AUC? Like, is anybody at the schools? Like, none of the students are there?
No, sir. Everybody's at home.
That's awesome. Cause like I get concerned if if they were there, cause like I think like Georgia State might be there. Like some of the schools are there, and I'm like, yo, and then it just sounds like it's pandemonium, kind of really. I mean, again, the college experience is a unique experience, but you still want to survive. Like you don't want to be dying for the college experience so much that you literally die. That's not what it is about. That's not what it's about. It's just about becoming free, becoming your own person, finding yourself as best you can, and finding your way. And just that thing of being out of the house, it totally like activates that whole thing. Let me see. Hey Google, give me a random number 1 through 21.
5.
5. Boo. I just did 5. Okay. Determine whether the function defines y as a function of x. Will this pass or fail the vertical line test? Or can you tell me what this shape is going to look like? We have the square root of x plus 38. Anybody? Square root function. Is that a function, yay or nay? Square root of x. So this graph is going to be the top half of a sideways parabola. If we have just the top half of a sideways parabola, something like this. Let me show you. So this graph is going to look something like this. Say here's negative 38 here. The graph is going to be like this. If the graph was like this, is this a function, yeah or nay? Does this pass or fail the vertical line test? So if this were the graph, this passes. Let me see how the text describes this. View an example. Same thing, just different numbers. Let's hit continue. So this equation is already solved for y in terms of x. Therefore, to determine whether the equation, substitute a few values for x in the equation. If 2 or more values of y can be obtained for a 1x, then it's not a function. Okay, so they're just doing like a plug and chug, guess and check. Okay, that's fine for this for right now. Is this a function? We're going to say yes. It passes the vertical line test. Hey, Google, give me a random number 1 through 21. I'm going to go 8.
Here's a random number, 21.
Okay, we did 21 already. So let's do 1. Let's do number 1. Is this a function, yay or nay?
Yes.
What would make it not be a function?
If there was 2 of the same value on x or y.
Yeah, if we have repeating x's, right? If we have repeating x's, then it's not a function. Okay. What's the domain?
3, 5, 6.
And tell me the range.
25, 22.
Okay, not bad, right? Hey, Google, give me a random number 1 through 21.
Here's a random number, 21.
What? Hey, Google, give me a random number 1 through 21.
Here's a random number, 9.
9, okay. Let's see. Numero nuevo. Nueve? I forget. I found a domain. Okay, x can be everything except what number here? What value of x makes the denominator 0? So notice x cannot be negative 3, so is the answer A, B, C, or D? If we want to capture everything except negative 3, then we choose A, B, C, or D. Do we need to go through this one? Hey Google, give me a random number 1 through 21.
Here's a random number, 2.
2. Any takers on this one before I go to the next one? I'm going to go to number 2. Domain and range. Is this a function? This is a... Okay, what's a domain? This is straightforward. We just did this one. Negative 3, negative 1, 0, 1, 2, 3. And then the range. Let's go 5, 3, negative 3, negative 5, and that's it. Any repeating x's? Is it a function? We're going to say yes. Hey Google, give me a random number 1 through 21.
18.
So when x is negative 4, what's the value of y? When x is negative 4, what's the value of y? Okay, let's see. So if we type 8, awesome. Hey Google, give me a random number 1 through 21. see 4. Okay, is this going to be a function? Is y going to be a function of x? Yes or no? What do you think?
I'm saying yes.
So let's solve for y. If we solve for y, how do we get rid of that square? What do we have to do on both sides?
Square root.
So when we do square root, what symbol do we have to introduce again?
Plus minus.
Plus or minus. If we introduce plus or minus, is it still a function? No, right? So this is going to be no. Again, because y is to an even power, when we take the even root, it kind of no longer makes it a function. Okay. All right. Hey, Google, give me a random number 1 through 21.
12.
Wow. So we're going to go to 14. Vertical, yeah. Yes. Hey, Google, give me a random number 1 through 21.
5.
We're going to go to 7. Okay. Is y a function of x? So if we do the same thing, right? If we go to solve for y in this case, we can subtract the x cubed. We're going to get y to the 7. How do we get rid of that y to the power of 7? What do we do on both sides?
Square it.
Yeah, it's called the 7th root, right? Like how we did square root, we could do cube root. This will be the 7th root on both sides. Because this is odd, do we include plus or minus yes or no? Do we include plus or minus yes or no?
No.
No, right? The plus or minus only comes in if this were even, right? If we did like square root or 4th root or 6th root. So because this is odd, we don't have to include the plus or minus. So then that's going to allow it to continue to be a function. So we're going to say yes. Okay. It's very subtle, and all of that, it really just boils down to this in this example. The exponent on y. Hey, Google, give me a random number 1 through 21.
Here's a random number. 12.
Okay, so let's go to 15. Is this a function? I'm just going to answer this one. All right, real quick, easy. Let me know if I need to go into details on any of these. Hey, Google, give me a random number 1 through 21.
Here's a random number. 19.
Okay, so this one says the perimeter of a square tile is a function of the length x of a side of the square. Find a function rule for the perimeter and find and interpret p of 10. Can anybody give me this result? Just take a moment and see if you can find the result here. Okay, take a moment to see if you can do this one. It says the perimeter of a square tile is a function of the length x of a side of a square. Write a function rule for the perimeter of the square and then find and interpret p of 10. So can anybody either give me the final answer or the function here? Let's take 10 minutes. Hey Siri, set a timer for 10 minutes.
Okay. 10 minutes and count.
And I'll just kind of be monitoring. I'll give you some time to think about it. And I'm nearby. Ooh. Let me put all this back. Okay. Okay. Can anybody like walk me through like what's the strategy here? Either a place to start or anybody give me an idea. How can we approach this? What would you do? Any takers? No? Okay. I'm going to leave it as an exercise then. No takers?
I got an answer.
Okay. What you looking like?
100.
100. What does that mean? So you're
X
saying
equals 100.
you said x equals 100? P of 10, right? You're saying that P of 10,
Yeah.
10 is 100? Let me see. Perimeter, how did you get that? What did you do?
I squared 10.
It says the perimeter is a function of the diagonal. Write a function rule for the perimeter of a square. Oh, okay. Yeah. That's not bad, right? That sounds okay. Let me see. Perimeter, right? Okay. So I think what you found was the area, right? Area is length times width. What does perimeter mean?
I think I have the answer.
The outside, right? So if it's a square and all the sides are 10, then what's the perimeter going to be?
40.
40, right? 10 plus 10 plus 10 plus 10, or 4 times 10, right? So the function is going to be, come on, are you frozen? Get out of here, Elsa. Come on. Okay, there we go. It's going to be 4 times x, right? Let's try that. That should work. And then it's going to be 40. All right. So I think initially what we found was the area. If we said length times width, that would be the area. The perimeter of a square of length side is equal to this value. Yes. Yeah, A, right. Hey, Google, give me a random number 1 through 21. Everything is slowing down. Okay, I'm going to choose 9. Everything except -3. So this one's going to be this one. Okay. Google's still thinking over there, so I'm going to go ahead and do another one. I'll do 10. Domain, okay. I think this one is everything except plus or minus 2. So the far left is going to be negative infinity up until -2, cup. -2 to 2. Cup. And then 2 to infinity. Okay. I think we're almost done. We're going kind of fast on this one. Google, you still thinking over there? You might not be working. Okay, can you give me the answers here? Like, if x is 0, what's the answer? I need to go to that. If x is 0, what's the answer? Right, so let's do this. Okay. If x is -3, and if x is 4, and So I'm going to write out that last one. So the last one, this is question number 8 from the text. Ooh, from the text. It comes from 1-3-19. It says that g of x, we got the square root 9 minus x squared under x, and they ask us to evaluate g of 1/2. Right? Okay. So then what we're going to do is 9 minus 1/2 squared, square root, under 1/2. That's going to be, what is that, a fourth? So that's going to be 36 by 4 minus 1 by 4 square root under 1/2. Then that's going to be 35 by 4 square root of that under 1/2. To divide fraction, we can do keep, change, flip. So this becomes 1/2 times 2 over the square root of 35. These cancel. And then if we rationalize, we'll get root 35 over 35. That's the gist. Hopefully that wasn't too fast. Let's see how do we do that. We're gonna go this one. Simplify your answer, type an exact answer using radicals as needed. So we got the square root of 35 over 35. Cross our fingers. Awesome sauce. Okay. You have to stop me if anything is too fast or if we need to go back. Otherwise, I'll just power through. Okay. The recording of this should be streaming on YouTube, so that's going to be there. I think we're almost done. How much time? We got a good amount of time. Let's go question 3. Is y going to be a function of x here? All right. Notice that the highest exponent is a 1. This should be a diagonal line, like a regular line. It's going to pass the vertical line test. So we're going to go yes there. So this one. Okay, let me write this one out. I mean, you probably don't have to, but I'm going to write it out. So this is question number 11. All right. It comes from 1-3-27. We have f of x equals, the bottom is the square root of x minus 3, and it's under 2, right? Okay, and then find the domain. Okay. So let's start off with the square root. Remember, what kind of numbers can we not take the square root of? We cannot take the square root of what kind of numbers?
Negative.
Negative, right? So if we can't take the square root of negative numbers, normally it's supposed to be x minus 3 should be greater than or equal to 0, right? If it can't be negative, it's supposed to be greater than or equal to 0. But because it's in the denominator, we have an additional restriction. It can't be equal to 0. So we got to get rid of this equal to bar. It can't be equal to 0. So now if we solve this, we're going to have x is greater than 3. Let's graph that result. Here's our 3. If x is greater than 3, are we talking about the numbers to the left of 3 or the numbers to the right of 3? If x is greater than 3, are we talking about all the numbers to the left or all the numbers to the right?
Right.
To the right, right? So the numbers that we're considering are all these numbers going in this direction. What kind of grouping symbol does the 3 get?
It's regular inequality.
Does it get a square bracket or parentheses?
Parentheses.
Okay, yeah. It's parentheses. Again, it's parentheses. If there were a bar, then it would be a bracket. But because there's no bar, there's no bracket. So we're going to use parentheses. That's funky. I'm sorry. I'm just playing around with these new features. I can get down with it. It's okay. Okay. So this is our graph, and let me do like this. Too thick. That's better, I guess. If this is our graph, can we change the style of that too? Whatever. In interval notation, what's the far left that this graph goes? How far left does this graph go? How far left does it go?
3.
Yeah. The far left, it just goes to 3. How far right does it go?
Infinity.
Okay. Infinity always gets what kind of grouping symbol?
Parentheses.
In this case, what grouping symbol does the 3 get?
Parentheses.
Parentheses. All right. So let's see how do we do. We said 3 to infinity. 3 to infinity. Okay, let me see. We got a good amount of time. Let's see how many more. Oop. We got 2 more. Okay, we're just gonna knock them out. Okay, is -1, 2 a point on the graph? Is that one yes or is that one no?
Yes.
Yep, right? Because basically what it's saying, if we let x be -1, right? That's going to be -1 squared is going to be 1. So 3 times 1 is 3. This is going to be a double negative, so it's going to become 3 plus 1, which is going to be a 4. 4 minus 2 is indeed 2. So when x is -1, we definitely get a 2. So we're going to say yes there. Okay. If x is 2, then what's the answer? When x is 2, what's the answer? What's the output?
8.
8 sounds good. I think I got the same thing. Okay, let's see the next one. List the point on the graph, so that's going to be the point 2, 8. Okay, if y is -2, I think I'm going to write this one out. Yeah, let's write this one out. Ooh, I'm fading. All of a sudden, my energy's been like, whew, I was like, I want to keep it for right at about 10 minutes. So, hey, Siri, set a timer for 10 minutes. But honestly, if we finish, I think
Your timer is set for 10 minutes.
either we finish this or the 10 minutes goes off, whichever comes first. I think it'll be okay. Let's go. Let's see. So this is question number 16. This is question number 16. It comes from 1345. So the original we have is this f of x. We got 3x squared minus x minus 2. And then we're on part C that asks if we do f of x equal to -2, then it says what is x equal to. Okay, so we kind of work it backwards, right? Okay. So if we set y equal to -2, let's set y equal to -2 and solve. So we get this 3x squared minus x minus 2. We're going to set it equal to -2 and solve. So if we add 2 on both sides, we get 3x squared minus x. Oh, that goes to 0, right? They cancel. So then we can factor. We can factor out an x from both of them. We're left with 3x minus 1. Zero factor property, we're going to get x equals 0 or 3x minus 1 equals 0. So from here, we get x equals a third. Okay, let's see what those mean. So if y is 2, x is going to be 0 or a third. List of points on the graph. So we got 0, comma, negative 2. And we got 1/3, comma, negative 2. Okay. Okay, the domain. So this is a U-shaped graph. It's a parabola. Can you tell me, what does this negative 2 tell us? Anybody know that? What does this negative 2 here tell us?
The y.
Yeah, this is going to be our y-intercept. Because the leading coefficient is positive, what does that tell us about the parabola? Which way does it open? Up. So this is a polynomial. The domain of polynomials is going to be all reals. Okay. List the x-intercepts. So we have to set y equal to 0. I think I'm going to write this one out. This is part E. So again, the original, we have this f of x, 3x squared, minus x minus 2. X-intercepts. Again, for the x-intercept, we're going to set y equal to 0. So then we get this 3x squared minus x minus 2 equals 0. So we want to factor. We're looking for 2 numbers. I'm going to do some work off to the side. 2 numbers that multiply to give me negative 6. Let me see. We got negative 2 and 3. Oh, that's it. And add to negative 1. So it's not these two because they add to positive 1. So it's going to be 2 and negative 3, right? So I'm going to use the box technique to factor this. This is something my students showed me in the past. And I borrowed it from them. Okay, in the upper left-hand corner goes, and we're going to rewrite this using, okay. In the upper left-hand corner goes our leading term, which is this 3x squared. The bottom right-hand corner goes our constant, which is the negative 2. And then on the other diagonal, we want to break that middle green negative x. We want to break it up into 2 numbers we just found. So we got a negative 3x and a positive 2x, right? So what do the top 2 have in common? What can we factor out of the top 2?
3.
3 what?
X.
3x. What do the bottom 2 have in common?
2.
2. What do the left 2 have in common?
X.
X. And what do the right 2 have in common?
Nothing.
Something.
Negative.
Yeah, the negative 1, right? So then our claim is that that top line that you see at the top of the screen right now, the 3x squared minus x minus 2, factors into x minus 1 times 3x plus 2. Okay. All right. Oh, x-intercepts, right? So we're almost there. I'm going to go back to black. So then we get x equals 1 or x equals a negative 2/3. Okay. X-Intercepts. Integer, commas to separate. It doesn't say ordered pair. So we're going to do a negative 2/3, comma 1. Y-intercept. So for the y-intercept, we set x to 0, and it's just going to be negative 2. Oops. Okay, let's see one that we haven't. I think there's only... Have we done that one? Let's go 17. Okay, as soon as we finish this, this will be the last one. As soon as we finish it, we're going to call it a day. Okay. Refer to the graph of this. Find the domain of f. The domain, right? So the domain is the very left to the very right. So the far left, what's the far left here? What's the far left? Negative 9, right? The far left is negative 9. How far right does the graph go? Infinity. So we said negative 9, interval notation. So we said negative 9 to infinity. Are we done? What do we need?
Parentheses?
Is it parentheses or is it a bracket?
Oh, it's a bracket for the 9.
Okay, so the 9 is going to be a bracket because we actually reached the 9. What about infinity? It always gets what kind of symbol?
Parentheses.
Parentheses. Let's cross our fingers. Awesome sauce. Oh, that was it? I was just ready for like range, increasing, decreasing. I was ready for all of that. Okay, I think that's it. I think we did it all. Okay, so since we turned it in late, highest we can get is a 90%. That's okay, though. All right, guys. I think that's more than enough. I didn't really want to keep you much longer than that. Did you guys have any burning questions? Any questions? If there are no questions, so tomorrow I wanted to take some time to just kind of do a review on factoring. I just wanted to have a chapter, and we can, unless that's only if you guys don't have any specific questions. If you come with questions, we can talk about your questions. If there aren't any questions, then we'll take time to kind of get some practicing on factoring. Okay. All right, gentlemen, go ahead and do your exam 1. Enjoy the rest of your evening, and I'll see you tomorrow. Take care.
All right, thank you.
Yeah.
Thank you.